In the Near East Gallery of the British Museum, in a case that most visitors walk past without stopping, there is a small circular clay disc, 8 inches in diameter, both faces covered in cuneiform markings arranged in 8 wedge-shaped sections radiating from a central point. It was recovered from the ruins of the library of Ashurbanipal at Nineveh in 1853 by the same expedition that brought most of the major Assyrian collection to London. It was catalogued as K8538. For the better part of a century, it was studied primarily as an astronomical tablet, an observer's record of the night sky, interesting but not unusual in a collection that contained thousands of similar documents. In 2008, a research team at the University of Bristol fed the tablet's markings into astronomical simulation software and wound the clock backward. The software locked onto a specific date, a specific night, a specific sky over ancient Mesopotamia, and in one of the 8 sections of the disk, in a position the Sumerian astronomer had marked, with the symbol they reserved exclusively for a full planetary body, there was something that does not exist in our solar system anymore. Not a faint star that has since dimmed, not a comet that has long since passed, a planet, in an orbit where today there is only debris. If you want to follow the rest of these, the artifacts, the records, the parts of the official version of solar system history that do not have a clean answer, subscribe. We post a new investigation every week. Now, let me show you what is actually on the disk. K8538 is known in academic literature as the planisphere. It is the oldest star map ever found. The 8 sections of the disk correspond to 8 segments of the night sky as seen from Mesopotamia, and the simulation software used in the 2008 Bristol study was able to match the tablet's stellar positions to a specific moment in time with an angular error margin of less than 1 degree of arc. Less than 1 degree. Achieved without a telescope, without instruments of any kind beyond naked eyes and clay. The date the simulation returned was June 29, 3123 BC. The Sumerian astronomer who pressed these marks into wet clay was sitting somewhere in Mesopotamia on that specific night, recording what he saw above him with a precision that would not be matched by European astronomy for another 4,000 years. The tablet is genuine. The date is verified. The positions are accurate. These are not contested claims. They are the published findings of a peer-reviewed study conducted by researchers at a credentialed British university. What those researchers did not fully address in their paper, and what no official commentary on the planisphere has addressed since, is the body in the 4th section of the disk. The body that the Sumerian scribe marked not as a star, not as a comet, not as a temporary visitor to the night sky, but as a planet, in an orbit between what we now call Mars and Jupiter, in a position that is today occupied by nothing but scattered rock and dust, the honest concession before going further. The 4th section of the planisphere is partially damaged. The symbol the scribe used is legible, but the surrounding notation is incomplete. It is possible that the body being depicted was a bright asteroid observed on that specific night in 3123 BC rather than a permanent planetary object. The Bristol team did not make strong claims about it. Mainstream Assyriologists have generally interpreted it as a transient observation. This interpretation is reasonable. It fits within what the evidence strictly supports. It also requires us to accept that the Sumerians used their symbol for a permanent planetary body to describe a passing rock, which is a usage that appears nowhere else in the entire corpus of Mesopotamian astronomical texts. The Mul Apin, the most comprehensive Mesopotamian astronomical reference document that survives, maintains rigorous categorical distinctions between permanent stars, wandering planets, transient visitors, and temporary phenomena. The Sumerians were not careless record keepers. They had a category for everything. They did not mix their categories. And the symbol on K8538 in the 4th section is unambiguously from the category they reserved for worlds. To understand what they may have been recording, you have to understand what occupies that region of the solar system today. Between Mars and Jupiter, at a distance from the Sun of roughly 2 to 3.5 astronomical units, lies the asteroid belt, a ring of rocky bodies ranging from the dwarf planet Ceres, roughly 940 kilometers in diameter, down to fragments no larger than a grain of sand. The belt contains somewhere between 1.1 and 1.9 million objects larger than a kilometer across. It also contains a problem that planetary scientists have been quietly working around for decades. If you add up the total mass of every object in the asteroid belt, every rock, every fragment, every grain of dust, the sum is less than 4% of the mass of Earth's moon. That is not enough material to have formed naturally in that region of space. Standard models of solar system formation predict that the gravitational influence of Jupiter should have prevented material in that region from accreting into a full planet, but the models also predict that considerably more mass should be present than what is actually there. Something is missing. An enormous quantity of material that the physics of solar system formation says should be in that belt simply is not. It was either ejected from the solar system entirely in some ancient catastrophic event, or it was never a natural formation at all, or the region once contained a full planetary body that no longer exists, and what remains in the belt today is what was left behind after something destroyed it. The Sumerians had a name for it. They called it tiamat, and the enuma elish, the Babylonian creation epic that draws directly on far older Sumerian source material, does not describe Tiamat as a metaphor. It does not describe her as a goddess in the conventional sense. It describes her as a body, a massive planetary body occupying a stable orbit in the early solar system. The text describes a catastrophic collision between Tiamat and another large body called Kingu, one of her satellites, followed by a second impact from a body entering the solar system from outside, a body the text calls Marduk, sometimes translated as the great heavenly body or the planet of crossing. The collision in the enuma elish does not destroy both parties. It splits Tiamat. Half of Tiamat, according to the text, became the firmament of heaven, which early scholars dismissed as religious poetry, but which a growing number of researchers now read as a description of Earth's formation from the larger fragment of a shattered body. The remaining fragments, the text says, were scattered into a ring orbiting the sun. A ring the Babylonian astronomers knew well, a ring they charted with extraordinary care, a ring we call the asteroid belt. This interpretation was not invented by alternative researchers looking for ancient mysteries. It was proposed in academic form by the astrophysicist Tom Van Flandern, a former chief of the celestial mechanics branch at the United States Naval Observatory, in a peer-reviewed paper published in the journal Icarus in 1993. Van Flandern argued that the physical characteristics of the asteroid belt, including the orbital resonances, the composition of the major bodies, and the anomalous mass deficit, were more consistent with the remnants of a former planet than with material that had simply failed to coalesce. He called the proposed body Phaeton. The paper was published, reviewed, and then largely set aside by the field. Not disproven, not rebutted in any comprehensive way. Set aside. Van Flandern continued developing the hypothesis until his death in 2009. His work is still cited, still available, and still unrefuted in its core prediction that more mass is missing from the belt than any current formation model can account for. The cylinder seal designated VA-243 in the collection of the Vorderasiatisches Museum in Berlin adds a second layer to this record that is harder to dismiss than it is to explain. The seal, dated to approximately 2500 BC, shows a central disk surrounded by 11 smaller bodies in what several researchers have interpreted as a diagram of the solar system. If the 11 bodies represent planets counted outward from the Sun, the diagram includes a body in the position between Mars and Jupiter that is absent from the modern solar system. The mainstream interpretation is that the central disk represents a star, and the surrounding bodies are other stars or abstract divine symbols, not a heliocentric planetary diagram at all. This interpretation is more academically defensible than the alternative. It is also in direct tension with what we know about Sumerian astronomical precision, a civilization that could record stellar positions to within 1 degree of arc, and that maintained categorical distinctions between classes of celestial bodies with the rigor of a working observatory. The VA-243 seal has been in the Berlin Museum since 1889. It has been photographed, studied, and disputed continuously since Zechariah Sitchin first drew attention to it in the 1970s. No consensus interpretation has emerged. The debate has not been resolved. The seal sits in its case, and the body it may be depicting no longer exists in the orbit where it is drawn. There is a third thread that comes from an unexpected direction, and that the previous two records do not prepare you for. In 2019, a reanalysis of deep impact crater records on the surface of Mars, published in the Journal of Geophysical Research Planets, found evidence of an anomalous bombardment event in Mars's early history that the researchers dated to approximately 4 billion years ago. The bombardment was unusually directional. The craters it produced cluster in a pattern that is statistically inconsistent with a random distribution of impactors arriving from the general asteroid population. The pattern is more consistent with a single high-energy fragmentation event, a body breaking apart relatively close to Mars and sending a concentrated wave of debris across the inner solar system. The researchers proposed several possible explanations. They did not propose tiamat. The enuma elish was not cited in their paper, but the directional bombardment pattern they documented is precisely what the Sumerian creation text would predict if a planetary body in the region of the asteroid belt had been catastrophically fragmented in the early solar system. Mars would have taken the heaviest part of the debris wave. Mars has the most heavily cratered surface in the inner solar system. The correlation is not proof. It is a pattern that nobody has formally connected to the ancient textual record. The two fields, planetary geology and ancient Near Eastern studies, do not attend the same conferences. The gap between them is not being maintained by anyone in particular. It is simply never occurring to anyone on either side to look across it. Now the honest concession that this reading requires. The enuma elish in its surviving form dates to the first millennium BC. The Sumerian source material it draws on is older but imprecisely dated. The text was not written as an astronomical record. It was written as a theological and political document, a justification for the supremacy of Babylon's patron deity, Marduk. The planetary interpretation of its cosmological narrative requires reading religious poetry as scientific description, which is a methodological leap that mainstream scholarship has good reasons to resist. Van Flander's hypothesis, while never formally disproven, has not been adopted by the planetary science community. The missing mass in the asteroid belt has other possible explanations, including Jupiter's gravitational influence over billions of years, gradually ejecting material from the belt into the outer solar system. The VA-243 seal remains disputed. The planisphere's fourth section remains incompletely legible. None of the individual threads proves what they collectively suggest. But what they collectively suggest is precise enough to be worth saying out loud. 3 independent ancient records, a clay disk, a cylinder seal, and a creation epic, all point to the former existence of a planetary body in the region of the asteroid belt. Modern planetary science has identified an anomalous mass deficit in that same region that no current formation model fully explains. The cratering record on Mars suggests a historical fragmentation event consistent with the destruction of a nearby body. And the Sumerian astronomical tradition that produced KD-538, a document verified accurate to within 1 degree of arc across 5,000 years, used its symbol for a permanent planetary body to mark something in that exact region of sky on a specific recorded night. What was it marking? The honest answer is that we do not know with certainty. The less comfortable answer is that we are running out of innocent explanations for why we do not. K8538 is still on display in the British Museum. The fourth section of the disk is still partially damaged. The asteroid belt is still in the orbit between Mars and Jupiter, still containing less than 4% of the mass that should be there, still producing no explanation for where the rest of it went. The enuma elish is still in every major academic library in the world, still describing in the oldest written cosmological language we have the moment a world in our solar system was broken apart. The Vera Rubin Observatory, which began its full sky survey last year, is the first instrument capable of detecting and cataloging small bodies in the outer solar system in sufficient volume to reconstruct the belt's original mass distribution from what remains. Within the next decade, we will know with real precision how much mass is actually missing and where the orbital dynamics suggest it went. The Sumerians pressed their answer into clay 4,000 years ago and put it in a section of a disk that has been sitting in London since 1853. The planet they marked is gone, but they marked exactly where it used to be, and they marked exactly what they thought had happened to it. Next week, we open the enuma elish itself and read the passage that describes what hit Tiamat, where it came from, and what the Sumerians said it does when it comes back. Subscribe before that one goes up. The video on screen covers the related case of K2486 and the star the Babylonians recorded going dark in a region of sky where modern radio astronomy has since found something it cannot fully explain. Click it before you go.